Welcome back. For this lecture, we will be discussing polymorphism. Polymorphism, as defined in the book, is a variable of a subtype can refer, a variable of the supertype can refer to a subtype object. The advantage, and I want to talk about the advantages first and then give you an example. The reason why I'm doing that is just I think it will make understanding polymorphism a little bit easier. Remember, this is object-oriented programming, and I think the most important principle to object-oriented programming is inheritance. Something like polymorphism allows me to make object-oriented programming easier to manage. As you can remember, I can be a class creator, and I can have the files that I've created, or let's say a particular file that I created, to be a parent or a superclass. I can have anyone else, any other class users, a wide range of class users, extend my superclass into their class files, and they become subclasses of my super. Without polymorphism, I need to know how they plan to use their code. Otherwise, there may be some compile errors or runtime errors. With polymorphism, I no longer need to know what's going on. A class user can use my code as they see fit, and I am completely oblivious to it, and I can continue doing things that are more pertinent to whatever I have on my plate. So let's go into an example, but just let's keep that in mind. This concept of let's make inheriting easier for not just the class creator, but also for the class users. And I will go into let's start with main vehicle.java. I have different examples here. The only one I'm going to look at for this particular lecture is the polymorphism example. This method is going to go into this poly example. So let's look at it first, and then I think I'm already running it, but we'll end it and we'll run it again. So in the poly example, I have a car and I have a bicycle. Bicycle and car both extend vehicle. Vehicle has a display speed that it will just print out the speed of each of the object that's passed to it. So let's quickly look at car, bicycle, and then we'll look at vehicle, and then we'll run everything. So let's start with car. Let's just go in order. Let's start in car. So car has the second constructor here, which we'll call. We're using a super keyword to refer back to my vehicle, so refer back to the superclass, and I'm passing in an int and this string. So let's match this up where he is in vehicle, so we can figure out what's going on here. In vehicle.java now, I have, here's my constructor that matches the signature from the super call in car.java. So passing in speed as well as a string, and I'm just assigning these guys to my members. So speed becomes the speed of this becomes this member, and then this v type, or I'm calling it vehicle type, becomes this guy. So v type is just what type of vehicle we have. In car.java, I'm going with car. In bicycle.java, I think I go with bike. So it's just a way for me to identify which object I have. Now let's look at the display speed. So this is a static method. You can only be referenced through the class. This is a member of, or a part of the class, not a particular object. Display speed takes in a vehicle, and it just prints out the speed. It prints out the v type of that particular v object as well as its speed. Okay, so let's go ahead and bicycle does the same thing. So bicycle is the constructor here. We just pass in the initial speed and the word bike. So let's go ahead and run these files and see how this works. So I'm going to end it, and I'm using JGrasp just so I can debug and step through this and have you guys see what's going on. I'm going to clear my output. So let's go ahead and run this file. So we're inside poly example now. Let me go inside this method. So we're inside the constructor. We're now going to call the vehicle constructor that matches the signature. So let's go inside that. We are now inside vehicle.java, and here is the constructor we're in. So we're setting speed instead of v-type. And if you guys have forgotten what it is, speed is 10 and the v-type will be car. So let's just move down through that. Okay, so we're done with the car. And I'm going to put up the lines of code so we can see where we are. So we're done with line 17. Let's go ahead and go to line 18. So we're at line 18 and we're going to go inside the code here. Bicycle does pretty much the same thing as car.java. The only difference is instead of car, this says bike. We'll go inside the constructor for this guy inside a vehicle, and we'll just walk through these guys, and we are now done. So now we're on line 20. Vehicle display speed. I'm just going to skip. We're not going to go into him. We'll just see the output of this code down here. So the speed of car is 10, and then let's look at the next one. The speed of bike is 5. So let's go back to vehicle.java, shall we? I want you to look at what's going on in the signature. And this is a polymorphic example. Oh, I'm sorry, an example of a polymorphic call. Display speed is not accepting car, is not accepting bicycle. It's accepting the parent vehicle. That's what we mean by a polymorphic call, is where I am referring to a subtype with its parent type. Now, here's why this makes object-oriented programming powerful. I could have a method called display speed and inside the parentheses have a bike, and then do method overloading and do the same thing, and instead of bicycle have car. Okay, I can easily do that. But let's say months later somebody wants to create the speed for a jet, and months after that somebody wants to create a an object called submarine, and a month after that someone wants to create another object of skateboard. So now we have different objects, and every time a new object or a new class, I should call them classes. So we have a jet class, a submarine class, a skateboard class on top of the bicycle class, as well as the car class. So we started with 2 classes, and now we have 3 more classes. For each of those classes, guess what I would have to do if I was doing method overloading? I would have to write 3 more methods, and each method would just change the name of the object that I'm looking for. So I would have a method that accepted bicycle. I would have a method that accepted car. I would have a method that accepted submarine, a method that accepted jet, and a method that accepted skateboard. That can get kind of difficult to manage, because I, as the class creator, would need to know how all my class users plan to use my code. With polymorphism, I do not need to know that. With polymorphism, all I need to say is you're going to, as a class user, refer to the parent of whatever you're extending. And it makes my job much easier as a class author. It makes your job as a class user much easier. Now, just to be clear, polymorphism does not mean this has to be done inside the class we are referring to. In this particular example, we are doing this inside of vehicle.java. I don't have to do this inside of vehicle.java. This or this could be whatever it wants to be. Polymorphism is not constrained to just the class it exists inside of. Those are completely independent. Polymorphism is only where I am referring to a subtype by its parent. That's all polymorphism is. So I just want you guys to make sure you're clear on that. So that is the polymorphism example. If there are any questions, please let me know. Otherwise, that will conclude this lecture.